Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all of you. Now, we would like to study on solving ordinary differential equation using Laplace transform. As I said to you, this chapter, its ultimate goal is to solve the ordinary differential equation, which we already learned how to solve it in chapter 1 and chapter 2. But for this one, we will focus on solving ODEs. It's either first order or second order, but focusing on using the Laplace transform method. Okay, so we have discussed on how to find Laplace transform and its inverse given any type of function. The use of Laplace transform provide an alternative method to those discussed in chapter 1 and chapter 2 for solving linear ordinary differential equation. We have discussed all the techniques that are required in solving problems related to the Laplace and inverse Laplace transform. Later, in this section, we will apply the knowledge that we have gained in previous lesson to solve ordinary differential equation with constant coefficient. First and foremost, we need to derive the Laplace transform of derivatives such as f prime, f double prime, and so on. So in solving the ordinary differential equation using Laplace transformations, okay, so if you have the function of ft be a function of t, therefore f prime and f double prime are the first and second derivative of the ft. The Laplace transform of ft is the capital F in terms of s. Then, okay, you can see over here, we will have the Laplace of the function of ft, you got the fs. But if you want to Laplace the function of f prime, so you will get this notation as fs minus f0, where f0 here can be found in the boundary condition given, and so on. We go for the f double prime and until f power of n. F power of n over here means that the derivative of n time. Okay, so as you can see from the derivation, in general, the Laplace transform of derivative is depending on value of when t equal to 0. Therefore, it can address problem involving initial value problem for linear differential equation with a constant coefficient. Okay, I believe that you will more understand when we go for example and its solution. Okay, so let's say if you have one problem and that problem is an initial value problem and you want to solve it. So the keyword from this equation is solution. Solve a solution. So the solution means here is we want to find y. As usual, we want to find what is y. What is the y? So this is the keyword of this question. In order to solve these types of questions, what you need is, okay, so you need to transform every single thing is either in left hand side or right hand side using the Laplace transformation. According to this one, look at, we have the first term, second term, and third term, and this one basically the boundary condition. Okay, for the first term, so basically here is the y prime. So according to this one, when you want to Laplace the y prime, so you will get as y capital S minus y 0. So it's here. So you Laplace each term. So Laplace each term over here. So when you want to Laplace the y prime by referring to the given notation over here, so what you will get is s ys minus y small over here 0. And then when you want to Laplace the y, so as usual you will get ys. And then in the right hand side, when you want to Laplace t squared, so what you will get is 2 factorial and s power of 3, which is 2 plus 1. So in here, okay, when you insert back over here, so you will have this one, and this one. So basically, this one is your boundary condition. So when you already have the answer of the boundary condition, you just replace it. Then you replace this one as 1. Okay, when you have this value, so you can bring the -1 from the left hand side to the right hand side. So that's why you have the +1 over here. And now you want to factorize the ys. So when you factorize the ys, so you will have s plus 2 over here. Just factorization. So now you need to find what is your ys. Okay, in order to find the ys, you bring s plus 2 to the right hand side. So from here, you what we call it, make it the simplification on x denominator. So it will have 2 plus s power of 3 over s power of 3, and then you bring s plus 2 over here. So you will end up get ys is equal to 2 plus s cubed over s cubed s plus 2 over here. So as we know that our ultimate goal is to find yt. So you know that in order to get the yt from the ys, you just need to inverse. So you need to inverse every single thing. All the terms in the left hand side and all the terms in the right hand side. When you inverse the ys, so you will get yt. So this is the one that we want to find. So means that here you need to continue and inverse the right hand side over here. However, in order to solve the right hand side, it's not that easy because you cannot get the solution from the table. So you need to use the knowledge that we have learned previously, where we need to apply the inversion by partial fractions. So you know that this is the linear, and then also this one is a linear. Okay, so when you want to have a linear over here, so you will have a over s, and then we have power of 3 here, means that it's repeated. So we have b s square, c s cube, and d for the s plus 2 over here. So the next one, what you need to do is you need to make it its denominator is equivalent with the denominator with the one that you use to find the fractional form of equation. Okay, so from here, the one that I highlighted here, okay, you need to make sure that the denominator is equivalent with the denominator with the left hand side. So what you need to do is, so as usual, for a, since we already have s over here, we need to multiply with s square, and we also need to multiply with s plus 2. Okay, what about b? Since b already have s square, so we need to multiply with s, and we also need to multiply with s plus 2. Okay, while for the c, look at here, we already have s cubed, so we just need to multiply with s plus 2. And then for d, since we already have s plus 2 over here, we need to multiply with s cubed. Okay, so look at here. Okay, look at here. When you multiply all those things, so basically x over s cubed, s plus 2. So since the denominator for the left hand side is equivalent to the right hand side, means that you can equate the numerator. Look at here. So the numerator over here is equivalent with the numerator with the left hand side. So what you need to do is you need to matching the coefficient of the left hand side and the right hand side to find the value of A, B, C, and D. Okay, look at here. You may start with the S cube first, or you can start with S0. It doesn't matter. So you will finally get the similar answer. Okay, look at here. When we are collecting the S power of 0, the F power of 0 here means that we have a number. So look at here. Let's expand first. When we expand, we have A S cube plus 2AS square plus BS square plus 2BS plus CS plus 2C, plus 2C plus DS cube is equal to 2 plus S cube. Okay, you can see that for the we have S power of 0 in the right hand side over here, so it's equal to 2, and then for the left hand side, for the constant, we only have this one. So we have 2C is equal to 2, and then it's done for this one. Okay, what about S power of 1? S power of 1 in the right hand side, we have no, so means that it's equal to 0. What about S power of 1 in the left hand side? So we will see we have 2B and then we have C. So 2B plus C. So done for S power of 1. We go for S power of 2. In the right hand side, we didn't have a S power of 2, so it's 0. And then for the left hand side, we have here 2A, and here we have B. So we have 2A plus B is equal to 0. And finally, for S power of 3, S cube, in the right hand side, we have coefficient 1. So we have 1 over here. And then for the left hand side, we have A, this one, and also we have here D. That's why we have A plus D is equal to 1. So now, this is the equation that we want to solve simultaneously to find A, B, C, and D. So how to find A, B, C, and D? So I believe that every one of you are able to find A, B, C, and D. Even if you can use calculator, you will get the same things, or you can solve directly and substitute the value, then you will get the correct answer. Okay, so let's try to solve here. So when you have 2C equal to 2, your C is equal to 1. So it's very easy. When you have C equal to 1, so you have 2B plus 1 is equal to 0. So you will have B is equal to negative 1 over 2. So this is your answer for B. Why you can get the answer for A? Because of you have 2A plus B, negative 1 over 2 is equal to 0. Okay, so you will have 2A is equal to 1 over 2. So your A is basically is equal to 1. Okay, you will have your A is equal 1 over 4. Please be careful. And then finally, you will have your D, where you will have 1 over 4 plus D is equal to 1. So your D is equal to 3 over 4. So this is your D. So when you have all the coefficient A, B, C, and D, so you put again in the partial fraction, and then you will end up having this one and this one. So basically, you want to find YT. So you inverse the left hand side here. So you inverse the left hand side, so you will get YT. So you will have YT over here. Here you will get YT. And then for every terms in the right hand side, you need to inverse it. So when you inverse 1 over 4s, look at the table. So you will have 1 over 4. Correct for this one. What about negative 1 over 2s squared? So when you have this one, remember, you will have 1 over 2 and you will have 1 over s, 1 plus 1. So here, basically, you will have 1 over 2t. So that's why this is over here. And then same goes to here when you want to inverse. Okay, you want to inverse the 1 over s cube. So you will have inverse 1 over s 2 plus 1. So here should be 2. And then you will end up having 2 over here. You can put 2 over here. And then you will have 1 over 2 over here. So you will have 1 over 2t squared. So that's why you got this one. And finally, for this one, you want to inverse. You want to inverse 3 over 4. And you will have 1 over s plus 2. So here you can directly get from the table, you will get 3 over 4 is a constant, and this one you will get exponent negative 2t. So you will end up having the correct answer for your ordinary differential equation. First order ordinary differential equation. So I think it's just matter of step. So what you need to do first is you need to Laplace every term from left hand side and the right hand side. And later on, when you already have left hand side and right hand side, then you need to find back the t, so you inverse it. But along the way, you might need to use some techniques. Okay, for example, the inversion using the partial fraction, or you need to use maybe the property in order to get the correct answer. But if you understand what you need to do in order to get the correct answer, I believe you will end up having a correct answer and score full marks for these types of question. So thank you. We will continue again for the next question.